But firstly, I'd like to introduce David Abramson from FIT, and he's actually the acting director of the Monash e-Research Centre. So he's taken over from Chung, who has gone off to be vice president at University of Hong Kong?
Baptist University.
Baptist University in Hong Kong. So Dave's going to speak about international research collaboration.
Okay, thanks. If I stand up, will the mic pick me up?
Yes, it will.
Okay, because I like to roam. So thanks for the invitation to speak. First of all, apologies for not being here this morning. I would have liked to have heard what was said. But I had to go and give another talk, so hopefully I won't overlap too much of what was said this morning. So what I was asked to talk about was internationalisation and research and IT, I think. So that's what I'm going to try and get across. So as background to that, given that I'm acting director of the e-Research Centre, you might expect me to say just a little bit about e-research. So let me just set the scene for what's changing internationally in that sense, and just give you a feel for how that plays into the research that we all do now. So people talk about an epoch sort of around the internet, and it's sort of pretty rough, but there's very clearly a shift in the way research is occurring, and not just scientific research, but research overall, but a lot of the examples I talk about are in the science domain. So pre-internet, people talk about, someone might come up with a theory, they may do some experiments, they may do that, it's a little PowerPoint bug. They may do the experiment first or the theory afterwards or whichever, do some work, possibly in a very small team, and then publish some results and the like. And so the quintessential example might be, theory of relativity in the top right-hand corner. What we're observing is that there's a dramatic shift, and what's playing into this is the enormous potential of information technology and distributed information technology. So they talk about post-internet as things happening very differently. We're talking about very large teams. We're talking about, in the science domain at least, very expensive equipment with very hard questions. So you can sort of think of it in some sense that all the easy things being solved now, and now we've got the hard things to do. And so this is taking large collaborative teams, working together, drawing data from very expensive scientific instruments. For example, the picture in the bottom is sort of an example of a device like the Large Hadron Collider being built in CERN. Billions of dollars going into the infrastructure. Clearly, you're only going to have one of those. And the teams that come together and work on this are working globally. So they might work out, develop simulations, do analysis, and exchange information. And a very large component of this is groups of people needing to get together. And that's really what I want to focus on in today's talk. So when we look at the infrastructure that underpins that research paradigm, you find that we have everything is distributed. We have computers distributed for doing computation. We have storage devices distributed for storage, archiving, the data. We have instruments distributed, so like radio telescopes and synchrotrons and the like are first-class items in the research infrastructure. And we want to hook them all up. So people want to come together and take data from an instrument, send it to some computation, store the data, do some analysis, do some visualization, and then work globally. And I think you'll see that more and more of our researchers are working in this mode. To steal a catchphrase from a friend of mine, Peter Arzberger from the UCSD, he talks about these grids, these computational grids that underpin this as not just being communities of computers, but communities of researchers and people. And that's a very important part. The talk I gave this morning was about the computer side of it. What I want to talk about now is how the people can come together and how we can use the computers to help do that. You can't possibly read that on this screen here. I don't know if you can catch the top there. It says, this is the sequence of the human genome. This is the publication that came out of Celera's work on sequencing the genome. You'll see Craig Ventnor's name in the top left-hand corner. And you don't have to read it. What does that say to you? This is the team that decoded the human genome. Now, it just so happens they're all from Celera. all the little ones after people's names, they're all from the same organisation. But that should flag to you that there's been a massive shift in what's happening in science. And this is not just one case. There's more and more of this happening. Has anyone got their name there? I always like to ask just to check. So let me talk a little bit about an experience we've had over the last few years in a collaboration across the broader Pacific Rim. This is called PRAGMA. It's the Pacific Rim Applications and Grid Middleware Assembly. It's sort of designed to fit the acronym. But it's a group of e-researchers who've come together to try and build the infrastructure out, to try and build the applications, and to build these teams. And so you can see there from that slide, that's the current snapshot of the test bed, the PRAGMA test bed. And what that means is that there are people at each of those places, clearly. There are computers at each of those places, in many cases quite substantial computers. There are data stores in each of those places. There are instruments. And what we're trying to do is build the computational infrastructure out so that we can ask big questions. We can do big, in this case, mostly science, but in the general research agenda, pose big questions and try and pull them together. So you might find that you're accessing multiple data sets from multiple places because they've been captured locally, doing computation, pulling all that back together and working together as a team. This is a paper that, again, you don't have to read the fine text. I was told to make everything 22 points, so that's not the point. This is a paper that a number of us wrote last year on, in fact, the experience we had in building this test bed out across the communities. We actually wrote the paper using multi-party video conferencing, exchanging information around documents and the like, across multiple time zones, multiple cultures, multiple languages. It was probably one of the most challenging things I've ever done. But I wanted to highlight to you is, if you just take a look at the publication names, so these people are from UCSD, we're from Monash, there's some people from, I can never quite remember where they all come from, there's Taiwan, Singapore, Japan, and Thailand. So this group came together, this was a subgroup of the people working on the PRAGMA test bed, who got together to write up the experiences. And it was really quite an informative process that we went through. So it's not quite the same size of name as you saw on the Solera paper, but that's probably the paper with the most authors I've ever written. So if we're counting that, by the way, for RQF purposes, I guess I get 1/16 or something of a beanie point for that.